Hi, this is Mr. Bissonette with another episode of Math in the Classroom. Today we are going to work on being able to state the domain and range from a function. So I can state the domain and range from a function. So for Spanish-speaking students, this is dominio. Range is going to be rango. Work on building that association. All right, so before we get all the way just doing it from the function, we have to start out by understanding the parts of our domain and range from the graph. Once we have that, then we can take a look at the function. As far as today goes, we're going to just cover our quadratic functions. Later on, we'll post how to do our exponential and our linear. But quadratic's probably the toughest one, so we'll work on tackling that first. All right, to start off with, if we're looking at it graphically, there's a couple things we need to know. First of all, our domain, that is going to be all of our x values, and our range is going to be all of our y values. So the way I explain it to my students is, think if we're starting with our domain, our x values on our x-axis, if we were a little ant and we were walking along that x-axis, if we look up or if we look down and we see the graph, that's going to be part of our domain. So right there, that would be part of the domain. If our little ant was out here and he looks up, notice he would not hit any part of that graph, so that would no longer be part of the domain. All right, so let's make this an example. Let's say this is -3. Let's say this is -4. Let's say this is 5. And let's say this is 7. So again, our graph, if we're on the x-axis, it's going to go all the way from this -3 all the way out to the 5. So we're going to go from -3 all the way out to the 5. Now, a couple things that you need to know. We have this open circle and we have this closed circle. They mean two different things. So our open circle, this is going to go with our parentheses. The way I tell my students that you can remember, if you were to erase half the circle, you would have that parentheses. And this does not include the value. Okay, so that means we're going to get as close to -3 as we possibly can, but it can never actually be -3. Here with the closed circle, this is going to be a bracket. Okay, our bracket, our closed circle, that's going to be our bracket, and our bracket does include the value. Okay, so bracket includes it, circle does not include it. Parentheses does not include it, bracket does. Okay, the example that I give my students is like this. If we were talking about this, I was having this discussion with my PE students. If you run 15 minutes or faster, then you don't have to run the mile next week. Well, 15 minutes or faster, that includes 15 minutes. So that would be a closed circle, that would be a bracket. If we were talking about that same example with our open circle or our parentheses, I would say it like this: you have to be under 15 minutes. So 15 minutes no longer works. It has to be something that's under it. So 14:59 would work, 14:50 would work, 14:38 would work, as long as it is under 15, but it does not include 15. Okay? Parentheses does not include, open circle does not include that value, closed circle does include the value, bracket. So what I recommend to my students is right when you get the graph, put your parentheses with your open circle, put the bracket with your closed circle, and then go from there, and that will remind you what to do. So we're going from -3, that's going to be our parentheses, all the way to our 5, that's going to be our bracket. Now our range, we're going to start all the way down here. It does not include that -4, but we're going to go all the way up, and you can think of like that ant deal again. Instead of looking up and down though, now we're looking right and left. So if we see that graph at any spot, then we know that that's going to be part of the range. So we're going to start here at -4. We're going to go all the way up to 7. And again, we're going to have our parentheses and we're going to have our bracket. A couple things to keep in mind on this. We go from the smallest number to the greatest. Smallest number to the greatest. That's the correct way, and this is what we call set notation. There's also using our inequalities, interval notation, but I prefer this one. I think it's a little cleaner, and to start off with, we're going to give that. All right, so that is our domain and range from a graph. I'll go ahead, feel free to pause if you need to get those notes for this part, and then we're going to jump into that function. Okay. So if we were given a function, something like, let's say, f of x equals x squared plus 8x plus 12. And we are asked for the domain and range. Okay. First thing, let's identify what kind of function this is. This is going to be a quadratic. And I know that because I have a number up in the exponent. Okay, a little different than our exponential that has that variable in the exponent, but quadratic's going to have a number, greater than 2 or greater than 2. So there's our quadratic. Now, keep in mind, what does that mean? What does that look like? It's going to look something like this. So the most important part when we're doing the domain and range of our quadratic is figuring out what our vertex is. Once we have that, the rest is pretty easy. Okay, if you notice for the domain, this is going to get wider and wider and wider. So our domain's pretty easy. We're going to go all the way from -infinity to +infinity. And it's going to be parentheses with infinity. We always use our parentheses because we can't include all of infinity. But our range is going to kind of be determined on that vertex. So we have a formula for that. Our x value of the vertex is going to be equal to -b over 2a. I had a student a couple years ago. He gave me a perfect little picture to remember this. He said it's an upside down basket because it's a negative basket or opposite of b. And out is 2 apples. Okay, simple little picture, but the basket also looks like a parabola. We could have our point there for our vertex if you want to remember that, and it's going to be our -b over 2a. So with this equation, our a is going to be this invisible 1, and our b is going to be that number right in front of our x. So we're going to have -8 over 2 times 1. -8 divided by 2 times 1 is going to be -4, and that is our x value. Once we have our x value, then we're going to plug that in. So we're going to have f of -4 is equal to -4 squared plus 8 times -4 plus 12. Once we have the x value, we plug it in to get the y value. So here we go. Doing PEMDAS, we're going to do -4 squared, so we're going to have f of negative 4 is going to equal positive 16 plus 8 times negative 4 plus 12. And now we're going to go to our multiplying. 8 times negative 4 is going to be negative 32. So minus 32 plus 12. Now here's a little trick. I can't quite say this is a for sure thing, but if you notice, a lot of times when we are solving for the vertex, we always end up getting, once we do this part of it, we either get the positive or the negative of this value. So 16 minus 32, it would be the negative of that value. So we'd have f of negative 4 is going to equal negative 16 plus 12. And then f of negative 4 is going to equal negative 16 plus 12 is going to be negative 4 as well. Not my favorite example, but it is what it is. So if we were to graph this, some students were able to jump right from the vertex of negative 4, negative 4. Some students were able to jump right from that to the range. Other students struggle to visualize it. If you do, make a quick sketch of it. So we would go over negative 4, and then we would go down negative 4, and that's where that vertex is going to be. This parabola is going to open up. I know that because my leading coefficient is positive. If it's positive, it opens up. If that leading coefficient is negative, that's where it's going to open down. Okay, so now my range is going to start down here at negative 4. It's going to be a bracket because if we look to the graph, that graph, it's going to be a solid line. So it's going to include that negative 4. Negative 4 works. And then from there, it's going to go all the way up to positive infinity. Okay, a little bit trickier, but if you just kind of remember the big main steps. Okay, so step number 1, we're going to find the vertex. In that, we would use our negative b over 2a and then plug in. After that, sketch the graph. Okay, get a little sketch of the graph, and I think this really does help students after that. After that, all we have to do is state the domain and range. Okay, so again, that's kind of the simplified version, but that's what we have to do if we want to work on stating the domain and range from the function. And more particularly, this is going to be the domain and range from a quadratic function. Again, we'll, at some point in time next week, we'll work on getting our exponential and our linear. Those two are a little bit easier. This is the one that's a little bit more difficult, but that's kind of our shortcut to get there. So, again, thank you for watching. If you like this, feel free to like, subscribe. If you have any questions, feel free to put those in the comments below. Thank you for watching.